Good morning, class. Mostly juniors, I guess, at this point. Today we're going to just do something really quick. We're only going to do it we're going to find limits using graphs. So the tables part actually is not going to be for you guys. First thing you got to notice is what is a limit and what does it look like? Well, in order to find a limit, you're going to see this notation, and it looks like LIM for limit, and then you'll see as x goes to a number, c, of a function equals another number, which is the limit. So f is the function defined on some open interval containing the number c. F need not be defined at c. Basically what this means is as x gets closer to c but remains unequal to c, the corresponding value of the function gets closer to n. So as you get closer to the x value, the c value that they gave you, then you're going to try to figure out what the y value is. Alright, so I know that sounds confusing definition wise. Don't worry about that too much. Let's just look at how that works with a graph. Okay, so use the graph to show use the graph shown, there should be not a 2 there, to determine if the limit exists. If it does, find its value. So let's look at number 1. Number 1 says the limit as x goes towards -2. So I'm going to use blue for this one to show you what's happening. So I look at where x is -2, and I have to be on the graph, and I have to approach that value. So over here, if I'm coming from this way on the graph, I'm approaching it from that way. So notice how I'm approaching the x of -2, and then I also have to check the other side. As I pinch towards the point, I find that both of the lines are coming to the same y value. So this is the spot that we're pinching towards. I look at the y value, and I get that the limit as x goes towards -2 is just 1. And that's all you got to do. You pinch towards the x value, but you have to be on the graph. Let's do another one. I'm going to use green for the second one. Now it says pinch towards -1. So here's where x is -1 right here. So here's this spot right here. So if I'm pinching from both ways, it's approaching this point right here that I actually already covered, which has a y value of 4. So that means the limit is 4. Okay, let's try another one. Let's use, I don't know, what color have we not used? Orange. Now we're going to approach 1. Well, here's 1. So I go and find where the graph kind of is at 1. And as I go from both sides, I'm pinching towards that point, and the y value that it's pinching at is 3. So the limit of the graph as you're approaching an x value of 1 is a y value of 3. Alright, -4. Now we have to do -4. So this one's a little different. I'm going to show you what happens on this one. So here's -4, but notice how the graph, I'm going to use purple for this one. Notice how the graph is kind of broken at number 4. So if I go and find where number 4 is, I have this point and this point, okay? So as I'm coming around this line here, down here, I'm approaching that. But if I'm on the other side of -4, I'm up here on this graph, and I'm approaching that. So do you guys see how as you move your fingers from left to right, or I guess one from the left and one from the right, they're not meeting up at -4 like the other ones did? This is a case where the limit does not exist. Don't know if you guys are a fan of Mean Girls. I know that's getting older and older as time goes on, but there's a famous scene where she's at a math team thing and the limit does not exist. Well, that's a case of where the limit does not exist. Okay, so let's look at the other ones. Number 5 is when you're approaching the value of 2. I'll use black for this one. So here's x equals 2. Again, notice that when I draw a line up or down, there's 2 spots where the graphs are. So that means if I'm pinching from the left and I'm pinching from the right, I'm pinching at 2 different numbers. This one's getting to -1, this one's getting to 5. Those aren't the same, so therefore there's no actual true limit at 2 because they don't work. Okay, let's do 4. Now this one you might be confused about. It's very similar to the first few. So I'll use this color for that one. Here's 4. So notice how 4, this is kind of where you're at. Even though it's an open circle, that's okay for these, because we don't actually care about the actual value. We care about what it's approaching. So if I'm on this side of the line and pinching towards x of 4, and this side of the line pinching towards x of 4, you should notice that we're pinching towards a y value of 2. So that means that even though there's a hole there, it doesn't matter. It's all about what are we approaching. We're approaching a value of 2. Okay, so those are the limits. So the only time you don't have a limit when you're dealing with the full limit, you have to check both sides, is when there's like a gap. It's called a jump discontinuity, you could call it, because there's a jump from one part of the graph to the other. And so because of that, the graph doesn't line up and there is no limit for numbers 4 and 5. Okay, let's do the last 3. This is just, again, real quick, things you might see. So the limit as you approach 6. Well, here's 6 again. Now, here's 6, and here's also a point. Here's what I wanted to show you guys. Even though there's a value of, that's kind of weird. The scale's weird for this one, but let's just say that's what, 7.5. Even though this point exists at 6, 7.5, that's not the limit. The limit, you're still following the graphs. So if I'm following the graph, and I'm following the graph, as I approach the point on the graph, I'm actually approaching a y value of 3. So even though the actual value is 7.5 for y when you're at an x of 6, the limit is not 7.5. The limit is 3 because that's what you're approaching. Okay, number 8 is a similar problem that we had earlier. You can already kind of tell that if we're approaching an x of 3, we have these two branches that are split at that point. So it's from this way we're getting a 2. From this way we're getting a 5. Since both of those aren't the same number, this is the does not exist limit because it's two different values it's approaching. And here, basically when you just have a graph and there's a point on the graph and there's no hole or anything, the limit is the y value because it's just part of the graph. I'm approaching x of 4, I'm approaching an x of 4, I get that value. Well, what is that value? It's a value of 3. So when x equals 4, y equals 3, that one, it is also the point, opposed to number 7 where the point is somewhere else. But in this case, the limit and the point are the same. And we're going to talk about that next lesson, which means that it is continuous. Okay, so that is it for finding limits with graphs. We only have 2 more to do, so keep up the good work, and we'll see you next time.